Welcome to another video of Stat 212. In this video, we're going to talk about describing data using measures of center specifically in this video. So we're going to talk about kind of representing and describing collected data. And the reason we do this is because of what you see right here. Here's some raw data that was collected. This actually represents some data that I collected from my class in a previous semester where I asked them how many what their heartbeat was in a minute, or how many times their heart beat in 1 minute. And so I don't know about you, but if I look at this raw data, I guess I can gather some insight, certainly, but it's not very helpful this way. It's kind of messy. It's kind of hard to see what's going on in this data. So it's probably helpful for me to kind of visualize this data and summarize this data in different ways. So we're going to kind of begin to talk about that in this video. So one way that we can visualize the distribution is with graphs, and we could find what we call the distribution. So the distribution kind of refers to the shape of our responses, and that can kind of show us what range of responses we're seeing, as well as just kind of the frequency or density of responses and different ranges. We can also calculate some key summarizing value with descriptive statistics, which we're going to do in this video. All right, so one thing that I do want to point out, we talked about different types of data. This is technically discrete data. Now it's discrete data that has a lot of different responses though, right? So it's not like I only have 5 or 10 different responses. It's, it's in a way, it's almost continuous, because if I think about heartbeats in a minute, we could kind of make the argument that, even though that the whole number is really a limit of my instrumentation more than the variable itself. So I think it's also reasonable to think that this could be continuous data rather than discrete. Honestly, the distinction it doesn't matter that much, because at the end of the day, I'm just going to calculate some numeric summaries. And whether or not this is technically discrete or continuous, it's the fact that it's a broad enough range of responses, I can kind of treat it more continuous-like in my choices here. All right, so one descriptive measure that we can calculate is the mean, or sometimes we kind of refer to it as the average. So the mean would be kind of the formal name. The average is more of a colloquial name that you hear conversationally. Sometimes people use the average in sloppy ways. Sometimes people use the average when they're talking about the median, unfortunately. But we'll call it the mean, but sometimes we'll say the average as well if we mean the mean. So the mean is really the balancing point of our variable. It's where if we were to put all of our data points on like a kind of a scale or a teeter-totter and try to balance it, the balance point would be the mean if we were to try to kind of stack it in a number line. So the population mean, so if I think about these heart rate values as a sample, and they're representing some larger population, maybe we'd say that they're the heart rates of college students at this university or college students in general. Maybe that's my population that I'm kind of representing here. There is an average heart rate. There is an average number of beats per minute, and we could represent that with the symbol mu. So this is a Greek letter. You pronounce it mu. And this would be kind of that parameter that exists that hopefully I'm kind of estimating with my sample result. However, I don't know what mu is, but I can calculate what we call X bar, and that would be the sample mean. It's the mean of the data that we do have. So X bar would be what I can calculate here, and that's going to be calculated if I were to sum up all of my data points and then divide by the total number of data points that I have here. That would give me the balancing point of this variable. So we don't really care that much about doing this by hand in this class because that doesn't really buy us anything. Instead, it's just important for us to know what it is. It's kind of nice to know how you would do it by hand. I suppose if the aliens took all of our calculators and computers away, though I think we'd have bigger problems than calculating the mean, quite honestly, in that case. Rather, it's probably better just to kind of be familiar with the fact that we can do this in software as well, where I could import this data into something like RStudio, and then I could just calculate the mean of this variable using a command like this, which we'll certainly talk about and use later in the course. The median is another good measure of center. The median is going to be the midpoint. It's going to be the middle data point of this variable. So there's a lot of cases where the median can be a little bit more helpful than the mean depending on what we're looking at. So I'll mention that as an instructor, I find the median test score a little bit more revealing to me than the mean test score when I look at a distribution of test scores, because the median tells me where the middle person is, like what they're scoring, whereas the mean is going to be a little bit more responsive to outliers. It's going to be more responsive to, like, a few of those low scores or even some zeros and things like that. So the mean can be kind of difficult to use sometimes as a summary depending on what kind of data you're using, whereas the median can be very helpful in some situations. So for example, the median heart rate over here is 72. It would be the heart rate of the middle person if I were to order all this data. The mean, by the way, is 73.075. So that's extremely close, which means that I have probably pretty symmetrical data, or somewhat close to symmetrical data. There might be a couple, higher points, maybe some outliers. There's probably outliers on both sides, but the outliers might slightly favor the right side, or the data is just like slightly, clustered to one side in that case. But yeah, the mean and the median in this case are pretty similar, meaning that the data is probably somewhat close to symmetric, I would guess. So as an example, we can find the median from a small number of data points if we just order them together. So the median here is going to be the middle data point. If this is data right here, this would be the median. And if I have an odd number of data points, that's very easy. If I have an even number of data points, though, I do have to think a little bit harder about it because there isn't exactly a middle data point. Instead, what I have is two data points kind of sharing the middle, and then I would say that the median is going to be the average of those two middle data points. I just split the difference and call that the median. Now, in terms of symbols, we don't really have a good Greek letter for median for some reason. I honestly don't know. So sometimes I see people distinguish the parameter median as a capital M and the lowercase median as a lowercase m. And it might have to do with, I have some reasons why I think that the field doesn't actually have a parameter symbol for the median, because if we assume an infinite population, then technically there doesn't exist a median, I guess. But anyway, some people do use this kind of capital versus lowercase distinction, but that's just kind of an aside. So I got ahead of myself here and kind of already talked about this, but yeah, the mean and median have some distinctions, and one of them would just be that the mean is more responsive to extreme values, to outliers, and the median isn't really that responsive to those. All right, so here's a test example. I already talked about this, but if I were to calculate the mean and the median in this example, which one do you think is going to be lower? Do you think the mean is lower in this example, or do you think the median is lower in this example? So I will go ahead and answer that question. The mean is going to be lower. And that's because the mean is going to be more responsive to this data point right here. I guess I should kind of complete that arrow there. Oh, you know what? My window. Oops, not that one. This one. I'm going to put that over there. Okay. So the mean is going to be lower here because the mean is going to have to balance that data point in its calculation, whereas the median can still kind of stay in the same zone, right? Like this one data point isn't really going to change where the middle data point is. So the median is still going to be somewhere kind of up here in this cluster. The mean, I would guess, is probably a little bit lower, like right around here, because it has to kind of include that other data point. One other way that I like to talk about this is if we were sitting in a classroom. It's not really as effective if we're on a video here, but let's say we're sitting in a classroom and there's maybe 100 of us, and we are trying to figure out the mean and median amount of money in everybody's bank account. Well, if we're all just kind of normal, everyday people, then the mean and the median are probably going to be pretty similar, right? Assuming we don't have a lot of outlier values there. But let's say that somebody like Bill Gates or Jeff Bezos comes in, somebody who's really wealthy, And now we have to recalculate those statistics. Well, the median isn't really going to change because the middle value is still going to be about where it was. But the mean is definitely going to be affected by that, because if I have to add in like $100 billion into my numerator and I'm only adding 1 to the denominator, that's going to have a big effect on the mean. The balance point is greatly affected by that. But the median isn't really affected because the middle data point is still going to be kind of in that normal, bank account range, I would suspect there. So quartiles is another measure that we talk about here, and these are measures of position, not necessarily just measures of center. So quartiles can be helpful to kind of summarize the positions of the 25th percentile, the median, and the 75th percentile, as well as the minimum and the maximum value. So the 50th percentile, by the way, is the median, right? So it's the point such that half the data is below it, half the data is above. So 50th percentile is the median. And then Q1 and Q3 are going to be our 25th and 75th percentile. And then the minimum and the maximum are just what they are. They're the lowest and the highest data point that we have in this particular sample. And we like to put these together into something called the 5-number summary. So the 5-number summary is just a list of 5 numbers that at a glance can help us kind of see the distribution of this variable. So imagine instead of just having all this raw data, I'm looking at it and I'm like, I don't know what to do with this. This is overwhelming. But then I just look right here. And this is a lot easier to read. It's a lot faster for me to understand what's going on in this data just looking at this set of numbers. Now notice here, though, that this is output from R if I use the summary command, and R always adds the mean in here as well. So technically, this is not part of the 5-number summary, but it is part of the summary output that R would give you if you ran this command. So technically, this is my 5-number summary right here, and then the mean is just kind of extra. It's R just being extra generous when we run that command. All right, so let's go ahead and find the 5-number summary of the test score data just for practice here. So the minimum and the maximum are easy. That's just going to be 24 and 100. That's going to be my minimum and maximum. Now the median is probably going to be the next easiest thing to calculate here. It's just going to be the middle data points. If I just kind of go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Doing this by hand is a little bit tedious, but I suppose doing it once by hand might be helpful. I have 22 data points. So the median is going to be right here. It's going to be the average of these 2 middle points. So I have even number of data, so the median is going to be the average of these middle 2. So the median is going to be 89 here. Now the quartiles are a little bit trickier because they're going to be the medians of the lower half and the upper half. So Q1 is the median of the lower half here. So here I have an odd number of data points, so it's just going to be this one. This would be Q1. And Q3 is going to be the median of this upper half. So it's going to be 12, 13, 14. It's going to be the 17th one here. So 94 should be Q3 in that case. So hopefully that was helpful just to do it by hand, but don't worry, we use R traditionally for this anyway, so this is not something we're normally going to do, mostly just kind of for example, and maybe for a homework question or an exam question, you might see a somewhat small data set to do the same thing.